Welcome. I would like to start out with a story. Once upon a time, a colleague of mine was working on a new feature in our application, and he was adding in a new endpoint to one of the services. And he noticed that when he was testing the service, that the JSON output had a date field which displayed in well, just ordinary Unix timestamp. And he thought, well, that's not very neat. It's better to have a formatted string. So let me just modify that, and it's better. So he modified it. He tested the new feature. It worked perfectly. He deployed it to production. Of course, not himself, but we deployed it to production. Of course, testing the new feature extensively. And the same evening, we got a call from the client, and he said, well, all the dates are on 1 January 1970 in my application. So what's happening? And we're like, oh. I want to use a curse word here, but of course, won't use it. So, as it turned out, our Java applications could parse the date perfectly, but there were some Angular frontends which did not expect a formatted string and just always returned January 1970. And that was not the only time we had a mistake like that. And it was not the only developer who made mistakes like that. We have other developers, all excellent developers, who just sometimes make mistakes. So we needed to do something about that. We needed to find a way to prevent mistakes like this happening. So that's why we looked at consumer-driven contracts. First, a little bit of history. We work at the Port of Rotterdam. We are employed by JDriven, which is a small consultancy company in the Netherlands. But Jeroen and I, we're working at the Port of Rotterdam, creating beautiful software for one of the largest ports in the world. It's the largest port in Europe. And we're allowed to make beautiful pictures like this for research purposes, of course. But most of the time, we're just developing software. So what kind of software are we making? Well, it's basically a management information system for the Port Authority. The Port Authority is responsible for managing the traffic in the Port of Rotterdam concerning safety, efficiency, everything that makes sure the harbor runs smoothly. So it's a big responsibility, and there are a lot of features in the system because, well, a port there's just so much going on in there. Ships are being inspected, for example, for dangerous goods or maybe some illegal stuff going on there. Everything is documented from which ship goes to which berth to prevent conflicts from two ships wanting to enter the same berth. So you can imagine it's a pretty complex system. So it started out as a monolith about 10 years ago, and it just grew and grew and grew. Well, you all know the idea. So we have all these responsibilities of the system, which are all entangled in one big spaghetti ball in the monolith. And we had a release cycle of about 2 weeks. So every 2 weeks we could go to production, and well, it was a bit traditional. And of course, everybody wants to do microservices these days, so we wanted it too. So we tried it, and well, instead it became some more like a distributed monolith. But before I go into that, the monolith, when we add a new piece of functionality or modify one piece of the puzzle, most of the time we just get a compile error when we forget that this piece of code is calling that piece of code. Or we get a unit test failure if you're lucky. But in a microservice architecture, or distributed monolith in our case, it's all loosely coupled, which is great because you can update all the individual pieces when we want to. We no longer need to release every 2 weeks. We can just push it whenever we want. But when you modify this piece, and you think, oh yeah, well then I need to modify this piece as well. Sure. But then you forget, oh wait, that service was also calling my service. I just forgot. If you don't have great test coverage, which of course we don't have, you get a runtime error. You don't get it at compile time. You might, if you're lucky, you get it, for example, during acceptance test or when you have great end-to-end test, you might find it, but you'll find it at a later stage. So this was not optimal for us, and we needed to find a way to somehow manage this, because it's not just a few services. When we started out with the microservices, we just pulled out one piece of the puzzle at a time, and we were like, well, we know how the services interact with each other. So when we modify service X, we know we have to also modify service Y and Z. But now we have about more than 50 microservices, which are managed by 5 teams, which all have different capabilities, different priorities, different agendas. So when you need to modify a service, maybe someone else has already modified another service which is using your service, and well, you can't hold it all in your head. So we needed a way to formalize the relationship between information producers and information consumers. For example, an information producer could be HTTP server, and the consumer may do a REST call to the HTTP service. So what do we do about that?
Right. So what we decided to do is look into contracts. And contracts are actually a formal way of describing the capabilities offered by producers and expected by consumers. And the things we describe in contracts could be like a schema, protocols, like do we use HTTP or do we use some messaging protocol, and the interactions. So when I send this type of request, I expect this type of response, or when I send this type of message, I expect this type of response.
So basically like a WSDL for XML.
Pretty much, yeah, actually. There's actually 2 main types of contracts that we're going to talk about, and those are producer contracts. Those are defined without cooperation of the service consumers. In fact, most of the time it's unknown who is using the service or how they're using it. And this is mainly suitable for public APIs like GitHub or Twitter. Basically, a situation where you can't actually sit down with all of your customers and say, okay, what should the service look like, or what changes can we make without breaking all of your stuff. Well, this is what it looks like in the picture. So there's producer A, which has a contract A, and which is consumed by many different consumers, which it probably doesn't know. There are also consumer-driven contracts. This is where the contracts are actually suggested by the consumers, which also means that the producer knows who those consumers are and how they are going to use the service. And this is more suitable for internal APIs. So it's actually more suitable for us at the Port of Rotterdam, because those 5 teams are actually on the same floor. We know each other. We can just sit down with each other and discuss what services should look like and how we can change them and how we can't. Well, here's a picture of that. Here you see actually a contract with, for every relationship between the producer and the consumer, you see one specific contract. This doesn't actually mean where those contracts are defined or where they are stored. That can still be with the producer, but the important part about the consumer-driven part here is actually, who comes along with the requests, who actually requests that there should be a contract. Well, this should be a familiar picture to every software developer, I guess. The test pyramid, where at the bottom we have the unit tests. They cover a very small scope. They should run pretty fast because we run them every time, usually when we build our application, and there's lots of them. Then on top of that, we have the integration tests. They have a bit bigger scope. They usually test a few classes together within one single component. We have fewer of those because they're usually a little slower, because you need more setup for the test to run. And then on the top there are the end-to-end tests, which actually usually test the entire system all set up, usually running on some environment somewhere. They're a lot slower because usually they operate through the user interface, so you actually have to, simulate user clicks, and it's usually a lot slower than just plugging in exactly right to the backend code. And they're also a lot more fragile because they're running on an environment where services may be deployed while your test is running, or where databases might be in maintenance or whatever. So they're usually a lot more brittle, and they fail more often because because of reasons outside of the application. Well, contract tests actually fit in right between the end-to-end tests and the integration tests. They're actually higher than integration tests because they actually test multiple services together, but they're lower than end-to-end tests because you don't actually need an entire environment. You don't need to simulate user clicks or whatever. So it's they can run a lot faster and a lot more reliably. So then we decided that we wanted to use contract testing, but then we needed to figure out how we're going to implement this. We've looked at Spring Cloud Contract. We've also looked at Pact. And we're actually leaning towards Spring Cloud Contract at the moment because of its integration with Spring Boot, which we use a lot. And if we do actually want to use Pact in the future, it actually integrates very well with that as well. So it's pretty safe bet from that point. So what does Spring Cloud Contract allow us to do? It allows us to define our contracts using either YAML or Groovy. It helps us to verify that all of our producers actually adhere to those contracts. We'll show you how they do that in a minute. And it also allows us to publish stubs for consumer integration tests. So if you're a consumer that uses a producer, you actually get stubs from that producer to run your test against. Well, to demonstrate all of this, we've created a very simple example application where we have a vessel position service which provides vessel positions to an Anchor application. And that Anchor application can actually be used by a Angular client. So the idea here is that the client tells the Anchor application that a ship is lowering its anchor. The Anchor application can then ask the vessel position server where the ship is, so that we know in which anchoring area the ship is at the moment. So what does that look like on the producer side? First, this is an example contract that we've done within this small demo application. So at the top here you can see we define a request with a URL and a method. And then we say what the response to that request is going to be. This is actually an example response that you could get from the vessel position service if you do this request. Then we also have a way to get more, verify more variable output, because not all latitudes and longitudes are, of course, 51.97 and 4. Etc. So you need to actually have a way to verify whether a response of the producer is actually a correct response. And you can actually see that we do this here by regular expressions to verify that those are two numbers with decimal points in them.
Over here.
Oh yeah, over there. Yeah. So on the producer side, we need to actually verify that whatever the producer outputs, that it actually adheres to the contract. Otherwise, contracts wouldn't really make much sense if you can just break them without noticing that. So what Spring Cloud Contract does for us with our plugin is actually generate a test. You don't need to read all of this code. It's just, this is actually, none of this is actually handwritten. So all of this is generated code. You can actually recognize those same regular expressions over here that we've defined earlier. So it will actually verify that whatever the producer outputs, that it actually adheres to that contract, to those regular expressions. What we do need to provide by ourselves is the base class for all of the tests, because obviously Spring Cloud Contract doesn't know what the inside of our application looks like. Spring Cloud Contract actually wants to use just rest assured mock MVC right over there. And this class actually allows us to wire our application up with rest assured mock MVC. So that's basically the setup that you see over here. All of the generated tests extend this contract verifier base. Now, we can actually do some fun things with those contracts. For instance, it might be very useful to actually use information from the request in a response. You can see that at the top over here. So you can actually use the request URL, your request path, and basically any information that you've supplied with the request. There are also different types of matchers, so you can actually check times instead of regular expressions. You can. There are also predefined regular expressions such as email addresses, and there are also, for instance, this is to check that a list has actually at least one entry in it. So there's lots of different ways to make verifiers for output. Messaging is actually done through Groovy contracts. It's not supported yet by YAML. So we have an example of that as well. Over here you see a contract where the application will actually output a message when a method gets called. So this could usually be because of a timer or some real world event. But this actually allows us to trigger the message in the application from any tests. The input could also, for instance, be another message. So then we would trigger this message by sending in a message to our stub. Here we define the output message. It gets sent somewhere. It has headers. It also has a body with fields. A distinction with YAML you see over here is actually that instead of using a body with an example output and matchers which do verifications, those are actually combined here. So the example output is actually the consumer part here, and the matchers is actually the producer part here. And obviously we do this for a lot of different fields. So on the consumer side, Spring Cloud Contract will actually give us a stub runner, which is based on the contract, so that the consumer contract test can run against that. So that will actually provide, actually be the producer for that consumer then. To be able to use the stub runner, we need to actually have a dependency on the stubs. This dependency is actually added by the Spring Cloud Contract Maven plugin, which just adds it to the build output actually of the producer. And this is actually a very standard consumer-side test. We run it with a contract test profile to make sure that, actually we have the auto-configure stub runner here. And that's actually the annotation that will start up the stub so that we can run requests against that. We use the profile here to make sure that this vessel position client, which usually goes to our backend service, now actually goes to the stub instead. But we don't have to actually mark anything. We can still use the exact same code from the vessel position client as we would usually do.
So it uses actual HTTP requests against a wire mock HTTP server started up by Spring Cloud Contract.
Pretty much the same thing for Angular projects, except we don't have a JVM running when we run a test there, so we need some other way of actually setting up the mocks. And to do that, we can actually use a Docker image provided by Spring Cloud Contract. So we just do a Docker run of the stub runner, and we tell it which version and which contract we want to use. It will start up the stubs. And then we can actually run our Angular karma tests. And in this case, we made an explicit script for just running the contract tests. Here you see what that karma test might look like. Notice here as well that we use the standard HTTP client module and not some sort of mocking module or whatever to mock requests, but we can actually do real actual HTTP requests. Obviously, we can customize almost everything about this stuff, so we can create our own contract formats if the YAML and Groovy don't provide what we want. We can create our own test generators. We can make our own stub runners, also stub downloaders. For example, there is one that actually downloads all of its stuff from a Git repository if you want. But you can also create your own. So now we can actually define our producer-consumer relationships in a formal way using contracts.
So let's see how that works out in a real-life situation. So imagine we have a vessel position version 4, which talks to Anchor version 9 using a contract with version 3. Specifically, the request that we saw earlier, a GET request for a specific vessel, which returns the location of the vessel in latitude, longitude. Say we want to implement some new functionality in the vessel position application, or maybe do some bug fixing. So how would that work out? Say we upgrade vessel position to version 5. This means that as long as vessel position version 5 compiles and runs the contract test against version 3 and they all succeed, there should be no need to modify Anchor. You should, if your tests are correct, of course, and complete, then you should be fairly certain that Anchor does not need to be upgraded and it can talk to vessel position version 5. So that should be a relatively easily upgrade. But imagine if you say, well, I don't like latitude, longitude anymore. Let's use X and Y or some other coordinate system. This, of course, would break the contract version 3. So we need a new contract version, which automatically means, well, Anchor should have a new version which could implement the new contract, and vessel position should also use a new version. So this, of course, on your development environment, you can easily upgrade all those components, and when the tests succeed, you should be fine. But that's just the situation in your local artifact repository. But in production, they still all have the old versions. So how do we go from this situation to this in a way that it doesn't break production? Because, well, at the Port of Rotterdam, of course, the port runs 24 hours a day. You can't just say, well, we'll just put the system down and then upgrade some components, and in an hour it'll all be up and running again. So we need some kind of some information about how we can safely upgrade services in production. And of course, acceptance and other environments first. So when we are deploying a producer, we need to know which consumers are consuming my contracts, the contracts that I'm producing, and specifically which versions. When we're deploying a consumer, of course, we need to know which versions of the contracts that I am consuming are being produced on the environment to which I'm being deployed. And am I compatible with these versions? And compatible may mean, well, versions match, then in which case you say, well, fine. Or when you're running, you can run the contract tests using the different versions. So for example, you can use the stub runner of the newer contract version and run your old consumer contracts against those against that stub. And if it succeeds, they should be compatible. And the other way around with the newer consumer contracts versus older stub runner, of course. So what do we need to answer these questions? Well, of course, all of the deployed services per environment and the versions. The contract versions produced and consumed by each service. And how to run the consumer contract test in case of a version mismatch. Well, there are some standard tools which allow you to manage the contract dependencies on your different environments. For example, Pact has a Pact broker which registers the different contract versions that exist in your system and the environments on which they are deployed. Spring Cloud Contract provides you ways to download stubs from your artifact repository or from Git, but we didn't have one tool which could help us complete the big picture and help us in our deployment pipeline, so we decided, well, let's build one ourselves. And we call it Contract Checker.
Right, so the contract checker actually is involved in two parts of our development process. Whenever we deploy a new artifact to our artifact repository, we tell our CI server to build a release. The CI server then builds it and deploys the artifact to our artifact repository, which is Nexus in our case. But then we add an extra step to actually register these contracts with our contract checker. So every artifact that's in our repository is actually known to the contract checker as well. So what does that mean to register a contract? We need to provide the name and the version of the service that we've just built. We need to tell the contract checker which contract it's consuming and which ones it is producing. Service can do both at the same time or one of each. And it should also have a Docker image with arguments to run the contract tests against a different version of a contract. So by default, it runs its test against a certain version. We do that during the normal build of the artifact. But whenever we want to check it against a different contract version later, we need a way to do that, and we use Docker images to run those. Then we also, when we deploy to an environment, we also use the contract checker. We tell our CI server to deploy a service. And instead of deploying it immediately, it does a pre-deployment check with the contract checker. And that checks against all the currently deployed services. So it checks all the version numbers of the contracts of the producers and consumers on the environment we intend to deploy to. Well, those tests either pass or fail. And if they pass, then the CI server actually does a deployment and then registers the deployment with the contract checker. This allows the contract checker, of course, for our next deployment to know which, to update the versions and the artifacts that are on a certain environment. To do a pre-deployment check or register a deployment, we need this information. So we need the name and version of a service and the environment we intend to deploy to. So they're actually the same for both steps. We actually decided to separate these steps. I mean, we could also do this in one step, like, okay, we intend to deploy this service to this environment. But we wanted a way to actually do a check without, actually deploying it, or to deploy it even if we don't want to do a check, just to, if for any reason we want to circumvent the checks. So far, we've actually implemented the registering of the contracts when we release an artifact to the repository. We do this by, for Maven project, we do this with a Maven plugin. And we can also match contract versions before we deploy. The things we have to do still is actually run these contract tests automatically if the versions don't match. So that's basically just starting a Docker run process from the contract checker JVM. We also need to be able to register contracts when we're releasing a non-Java project. So, for instance, JavaScript front ends. And we need to actually integrate with our build environment. But that's actually just using something like curl from Jenkins to do the pre-deployment check the outputs, and actually register it as well. So let's see what we've got so far.
So the Maven plugin Jeroen mentioned is already created, and it works when we deploy a new artifact to our artifact repository. Presentation mode.
Oh yeah.
So we've called it the contract checker Maven plugin. Well, naming is very important, of course. So what you provide is the URL of the contract checker, a Docker image used to run consumer tests, which in this case is a Git Maven combination of a Docker image, which provides the Git repository of the project, the tag, which is the released tag version, the path in which to run the tests, and in our case we also provide a Maven repository so you don't download the internet every time you run your tests. And this states that in the deployment phase of the Maven lifecycle, we run the register contracts goal, which registers our contracts with the contract checker. Yes.
Yeah.
So we'll just show some HTTP requests, and we'll show the response of the contract checker.
Let's actually start it first.
If you start it first, of course. Yes. Of course, a Spring Boot 2 application. Presentation. Okay, so our first request is just a simple GET request, which lists the services known to the contract checker.
Oh.
So what we see here, the first one, vessel position application, version 1.1. I'll skip the Docker arguments for now. It runs on the dev environment. It consumes nothing, and it produces the vessel position anchor contract, which is the contract between vessel position and anchor, version 1.0. And anchor application, which has version 2.1, also runs on dev, consumes the vessel position anchor contract. Scroll down a bit. And it's also version 1.0. And it produces anchor client contract, which contract between anchor and client, version 1.0, etc. Yeah,
and so on and so forth.
And so on. You get the picture. So now we want to deploy to the repository. So it's just upload to Nexus or Artifactory a new version of the anchor application, which is version 2.2, which still uses the same contract versions, which are already in the running version on dev. So still 1.0, 1.0. So we run that. Okay, status 204, it's okay, it's deployed without problem. And we run the GET request services again to see that it's indeed added to the list of services. And we see here anchor application 2.2, which is not deployed to any environment just yet. And if we scroll up, we'll see that the anchor application 2.1 is still there and still on dev. So now the contract checker knows both versions, but knows that 2.1 is on dev and 2.2 isn't yet. So now we want to verify if we can deploy anchor application version 2.2 to our dev environment. And it will say aloud, sure, go ahead. Because as a consumer, the results are valid because we consume the vessel position anchor contract version 1.0, and 1.0 is also produced on the environment, so that's okay. And the producer results are also true because anchor client contract version 1.0 is produced, and client consumes version 1.0. And of course, this is a list because one producer can have multiple consumers. But in this case, there's only one. So now we can say, okay, perform the release, deployment, I mean, and it's fine. And then we'll check the services again, just to validate that indeed Anchor application version 2.2 is deployed to dev, and 2.1 isn't anymore. So now, of course, we want to see it go wrong, go bad. Vessel position application version 2, which has a new contract, version 1.1. The first step is just to deploy it to repository, which should be fine. It just registers the deployment. But when we want to verify if we can deploy vessel position 2.0 to dev, then you'll see, well, don't do it just yet, because there's a contract conflict, because you're producing 1.1 and Anchor is consuming 1.0. So in this case, we should run some extra tests.
Okay, you want to show the producer side verification of the contract?
Yeah, we don't have much time left. I think it's better to
Okay, then we'll wrap it up.
Skip a small part of the demo because of time, unfortunately.
So, to recap, contract testing versus other tests. We've already seen they fit nicely between the end-to-end tests and the integration tests. They're less fragile than the end-to-end tests, and have a broader scope than the integration tests, which test just one component. It does take actually an initial investment, especially if you've already got all of your testing coverage in place. If you're starting out, then this is actually a very nice replacement for mostly integration tests, where before you would actually have to mock everything and write mock test content, and now you can just reuse that from whatever producer you are testing against. The added value for us would be increased confidence during service development. So that means that we can actually verify during development if we're still adhering to the contract, as well as service deployment, so that we can actually check that whatever we deploy to production, we have previously verified against each other with tests. Spring Cloud Contract, we choose that. It's not the only tool available, but it integrates really nicely with all of our other Spring Boot stuff and all of our Spring applications. So yeah.
So thank you. I think most of us want to go out for lunch, but so if you have any questions, just come to us and we'll be happy to answer them. And otherwise, have a great lunch. Thank you.
Thank you.